Hi everyone, this is Maniramakrishna now going to teach about the parallel operation of the alternator. So before going to the topic, so what we're going to explain in this module, let us see. So here parallel operation of the alternators. So you're going to know about the necessity of the operation of alternators in the parallel. So here the necessity of the parallel operation is that if power plants consist of one single unit, so we need the continuous power supply, and in the event the breakdown of the prime mover of the alternator, then it causes the damage of the power supply. There is no continuity power supply, so in this time we require the another alternator to give the continuity power supply. So if the only is one single units are there, then total power will be shut down. To avoid that, we are going to using another parallel operation with the alternator. So here, if several small units are in the parallel, if that is we're having the motor turbine alternator sets, we're having the small power turbine alternator set in the parallel operating. So if one unit fails down, then your power supply the remaining units also goes to the power. Okay, so here this means that if several units are there, so here meaning that continuity power supply means we having the if one generator, if only one generator, that is the one generator and the one turbine if we have, so if it is one is failure due to the power losses, there is no power supply to the RYB phase. Okay, to avoid these such a conditions, so we are going to using the parallel operation of the alternator along with the turbines. So here whatever generator output is there, that will give to the same alternator sets along with the turbine. So here we are using the different alternator sets, the small units, so all are run at the same speed, and that will give to the synchronous jam. So this is the parallel operation. So if it is one unit cell, then the entire pod will be shut down. To avoid that, we are using this type of system. Here the several small units are running in parallel. If one unit fail down, power will be supplied with the remaining units. And another thing is that to improve the efficiency, so the power plant efficiency will have small if using the one generator set, the improve the efficiency of the more plant, we are going to using the parallel operation of the alternator. Alternator operate the most efficient when the delivering the full load condition, and the voltage drop will be take place. To avoid that, we are going to use another alternate with the parallel way. So if its load is light, then single unit is be used. If the more load is increases, then another unit can be run in the parallel to share the load. Here another thing is that is easy maintenance. So when several alternators are in the parallel, one unit can be taken for maintenance, other unit can be run without interrupting power supply. So this is another thing, and remaining units will supply the load. If one units get breakdown, it can be separated easily for repairings. So extension of the power plant, so extension of power plant means to increase the power plant capabilities and having the power plants. To avoid that, we are going to using the alternators in the parallel. So nowadays the load demand is increasing the day by day, so power consumption also increasing to, therefore if alternators are connected in the parallel, extra units can be added without any difficulty to increase the capacity of the plant. So here one other thing is power consumption is day by day is increasing, to as well as the generation also we have to increase. So to develop the another power plant, hydro power plant, nuclear power plant, third plant, so it will take the much more time. So to avoid that, if you add another parallelly for the alternator, that will be easy for extra to as per increasing the demand of the power supply. If single unit is used, extension power plant is difficult. If parallel, if you connect the number of time parallel operation, that will be easier to extend the power plant. So here the summary, that for continuity power supply to improve the efficiency for easy maintenance. So these are the things are necessity of the for the parallel operation. And here parallel operation consists in the parallel operation alternator. The process of connecting two or more alternators parallel to share the common load is called the parallel operation of the alternator. Here, so what are the conditions we required for the parallel operation? Here, condition number 1, equal terminal voltage, and this is obtained by adjustment of incoming generator's field strength, like this. Here I'm showing the synchronization switch. It will having the different method synchronization. So we're having the three methods based upon the bright lamp method, 3 dark lamp method, and Synchroscope. So mainly some based upon the availability of the supply. So synchronization of alternator is used for the Synchroscope method, that is for best accurate method. So and another method, so we will having the bright lamp method, 3 dark lamp method, and mainly synchronization is done for dark lamp method and the bright lamp. In the dark lamp method we are having 3 dark lamp method and 2 bright lamp and 1 dark lamp method in that, and the Synchroscope is also one of the method. Here we will discussing about the only the parallel operation and the Synchroscope method for the synchronization. Here the condition due to equal frequencies, so the incoming frequency and the outgoing frequency should be same of the alternators. So he is obtained by the adjustment of incoming generator prime mover speed. So if the speed of the alternator, that is will cannot be controlled directly, to control the alternator the speed, that will be controlled by the prime mover, that is the turbine in case of the alternators. Here the line is, and the condition that the same phase frequency, that is the phase voltages obtained by the adjusting in connections to the alternator which connected in parallel, that is R phase, Y phase, B phases. So 3 phases are in the same frequency or not, that you have to check for the if connected the number of parallel operations of the alternator. Hey, the synchronization is the one of the thing this term which is frequently used in the parallel operation of the alternator. And these methods to connect the alternators in the parallel. So if they all connected, all alternators are connected in parallel or not, that will be checked by the synchronization of the alternator. Here we are having the total synchronization method is the term which is frequently used in the parallel operation alternator. The method is connecting the alternators in parallel is known as the synchronization. The method of connecting alternators in the parallel is known as the synchronization. So here the one is the method and the Synchroscope I'm telling about in this topic. So we have the different methods, 3 dark lamp method, 2 bright lamp method in the 3-phase alternators. So here the one of the thing, Synchroscope is also is the one of the best accurate method for the synchronization of the alternator. So let us see. So here is the Synchroscope. It is the motor having the pointer fixed at one end of the motor shaft, which is rotated over a circular scale fixed at the end of the shaft. So if here having the slow motion for and winding with rotor and the stator, so incoming bus bar connections and the incoming machine connections also connected to this one. So it will be look like this one. Here bus bar connections and generator connections will be connected to this one. So based on the frequency of the power supply, it will be shown in the generator is slow. If the generator is fast, that will be at which point the synchronization have to close the switch, that will be at this one. Here synchronous work in the principle of the rotating magnetic field, that is the RMF production. So here what the construction details of the Synchroscope, let us see. If the rotor and stator are supplied from the 2 phases, that is incoming of the machine. If the 2 phases are synchronous with the then It consists of rotor, stator wound, a two-phase system. The rotor and stator are supplied from the two-phase. If two phases are synchronized, then the third okay. Here, see it consists of the rotor and the stator wound, whereas the stator and the rotor part, and for showing the finger, for here having the needle like this, I show them like okay, and we will having the one needle that will show the how generator is going to the fast or slow, that will be shown. It consists of the rotor and the stator, rotor and the stator, and the rotor and stator is supplied in two phases, that will having two phases, incoming phases, supply of the alternator to be connected in parallel. If two phases are synchronized, then third phase will automatically be synchronized. That is a in the among the three, if two phases are synchronized, the another thing also, another phase also continuously in phase. Here the supply system Synchroscope is given existing alternator. The supply, the supplies rotor is synchronous given by the incoming alternator. The function of the Synchroscope, it indicates difference. It indicates difference in the phases and the frequency of the alternator, which is a two connected parallel. Like so, here it will be shown like the fast, slow, and frequency, incoming frequency, outgoing frequency. That will be shown if it is all are same or not. That will shows if it is the generator run at the above the incoming frequency above. Then it will show the up in details in like this. So if also indicates whether incoming current are running at the low or fast, that will be shown here. How is low, slow or fast, that will be shown like this. Okay, and the working working of Synchroscope depends upon the difference in the frequencies of alternator which are to be the connected parallel. So main thing is that Synchroscope works on depends upon the differences in the frequency of alternator which are to be connected in parallel. Here, if there is no frequency, if there is no difference in the frequency of the rotor and stator supply, then rotor remains standstill. That is that's showing that that means the dial of the remain at the standstill condition. If the difference is on the frequency rotor and stator, the rotor will be rotated. That means either clockwise direction or the anti-clockwise direction. So here, if the difference is the frequency of the rotor and stator supply, the rotor will start rotating depending on the alternator or bus bar. So if the difference of frequency greater, that is if difference in the frequency is greater, the rotor speed will be greater. Here the difference frequency is less, the rotor speed will be less. This is the how it will be shown. So depending upon the position of the alternator which has to be connected parallel, the needle of the synchronous curve will remain standstill, goes fast in the clockwise direction, the goes slow in anti-clockwise direction. So dial, if the dial at the standstill condition, as synchronous dial stop revolving, when then frequency of the supply alternators to be connected with the synchronization and parallel. Okay, in the clockwise direction, when the dial is in show in the clockwise direction, that is the too fast. Here the Synchroscope rotated in the will try to rotate in the clockwise direction. Speed is incoming is too fast. In the anti-clockwise direction, it will the Synchroscope rotate in the anti-clockwise direction. The speed of the incoming missions is very slow. That means shows. Here this the process of the Synchroscope. So voltage adjustment will be done at the alternator is the first and the normal speed, and the voltage is equal in this way. So the alternator is the first and the normal speed, and the voltage adjusted equal to the bus bar voltage by adjusting the field excitation. So if it is a difference voltages are there, it is not possible to put the synchronizations. To avoid that, we have to run the alternator at the normal speed and put the excitation for the alternator. So after voltage adjustment, the Synchroscope switch is put on and the speed of the incoming alternator is adjusted. It is adjusted switch such a way so decreases speed of the needle Synchroscope. So if here, so at this point I'm showing at point 0 the show and the slow are fast in the here where they have the two alternators. They have the mission 1, mission 2, both are connected the infinity bus bars. Here where both voltages are same and speed also same, then if the frequency, there is no frequencies there, differences are there, the point shows the at the 0. So if it's one of the frequency will changes, that will based on the supply frequency. If it increases, it will show the fast. If the supply frequency decreases, it will close in the clockwise direction. So main thing will happen in the Synchroscope is only connecting the 2 phase, another we are connecting the 3 phase. Here after synchronization, what is happening, let's see. Here the Synchroscope is disconnected from the synchronization bus bar, putting off the switches to Synchroscope. So if it is both are synchronized, that is the two missions are connected to the same frequencies, then putting up the synchronization, then alternate connecting synchronous using the Synchroscope. Okay, this is about the parallel operation of the alternator and synchronization method by using the Synchroscope. I hope you understand this method is nothing but the two alternators working the parallel. So if it's one alternator we are having the only one, so if it is one of the machine having the problem, that means, and let us see the summary of the topic. If if you have the only one alternator in the in the power plant, so if it's one alternator having a problem, so it will get the problem for the power supply. So to avoid that, we are using the another generator set to get the power supply's continuity. So requiring that is called as a parallel operation of the alternator. So to run the parallel operation alternator, we need these some conditions, that is the voltage, equal voltages and frequency here. So equal terminal voltages and the equal frequencies of the same phase sequences. So these are the three conditions for the parallel operation of the alternator. So using a Synchroscope, we are going to connect the two alternators in a parallel. I hope you understand this topic. Thank you. This is the Maniramakrishna for signing off. Thank you.